Good afternoon, everybody, and welcome to the SNZ webinar with NZIA on hybrid thinking, evolving steel timber design for New Zealand buildings. Appreciate everyone giving up their time and their lunch and lunchtime to come and join us. So, Steel Construction SNZ would like to thank NZIA for the opportunity for us to present to you today. My name is Darren O'Reilly. I'm the General Manager of SCNZ. And I'll just give you just a brief overview of SNZ. For those of you who don't know, we're the industry organisation for structural steel. We're similar to probably the best comparison as master builders. We're the master builders for structural steel. And we represent the entire structural steel industry in New Zealand. We're incorporated 20 years ago, almost 2006, and we have almost 700 company members. Now that ranges from throughout the whole supply chain in structural steel, from the steel mills through to distributors, the structural engineers, and through to the steel fabricators who manufacture and erect the steel, plus a lot of other companies on the great industry. We like to think we're the voice of the structural steel industry, and we do a lot to promote our industry, and that's why we're here today. But if you're interested, you can find out more about us on our website, which is pretty easy to remember. It's www.scnz.org. But one of the big things we're about is sharing knowledge and amongst our membership and the wider construction industry. That's why we're here today. So on that note, we've got two great guest speakers to speak to you today. First up is Wayne Carson. Wayne Carson sitting next to me. Wayne is the Managing Director of D&H Steel Construction, and he's also a past chairman of SCNZ. Wayne has a vast background in mechanical and structural engineering, and there's a wealth of knowledge spanning over 40 years in the construction industry. He has a broad range of experience from large structural steel buildings, steel frame housing to light commercial and industrial steel structures, as well as product and market development of innovative steel construction systems. So I can think of no better person to speak today, as well as the other speaker who will come after Wayne. However, before I hand over to Wayne, just a bit of housekeeping. If there are any questions, we'll have time for some question and answers at the end of the two speakers. During Wayne's presentation, I invite you to post any questions you may have into the Q&A panel. Please don't post the questions on the chat because we may miss seeing these things during the presentation. I'll collate most of the questions. We may not get a chance to get around to all of them, but we'll ask as many as we can at the end of the presentation. But with no further ado, I'd like to hand you over to Wayne Carson.
Great, thanks, Darren. I didn't feel very old until you talked about how many years I've been in the industry, but thanks for the introduction. I'm intending to just share some lessons learned more than anything else. Hybrid construction is obviously a future. We acknowledge that certainly in the steel industry, and I think it's important that we understand how to best use the different products and the different applications and how they fit together. So I'm going to touch on some of these areas, lessons learned from first generation. So I'm going to talk about some buildability. Oops, back. Some buildability interfaces. Something about planning on site. I'm going to touch on some learnings around just the maturity of the industry, where we're heading with that. A bit about coordination and sort of looking forward, what some of the ongoing considerations. Moisture content's one of those, and how do we take some of these key learnings forward. So compatibility expectations was and is one of the big things. It's really needs careful consideration when planning a project, and more particularly as you're detailing. There are quite significant differences in that expectation, so it really needs to be clear, needs to be talked about and discussed on how to deal with that. One of the things we've found, and I'm going to show you 3 examples of projects that we've been involved in, but one of the things we've found is just the a key difference is sort of dimensional variance that occurs through weather, particularly moisture, which then sort of translates into trying to come up with good buildable details that allow for a bit of variance and a bit of a changing variance. One of the things that we've seen change quite a lot is a bit of a demarcation between what we describe as steel to steel connections versus timber to steel connections. Some of the manufacturers now are offering some of those connections as part of their timber package. I know it is different from different manufacturers, but some now supply their own sort of timber to timber connections. So it's about sort of understanding that at the start and who's designing which elements and more particularly who's detailing each of those interfaces. And I should have added there timber to timber. So steel to steel, timber to steel, and then timber to timber are the three kind of generic areas that really need a lot of thought about from a detailing and buildability perspective. And sort of along with that is the planning and coordination for the on-site activities. Each of the projects that we've been involved in has had many critical path interfaces. They all are true hybrids. That is, they still have this, even though they may appear to be, largely a timber building, there is still a high content of steel elements and components. So all of those interfaces need careful consideration. And from a construction perspective, and certainly a main contractor's perspective, where he's sort of herding the sheep, if you like, it needs that close planning and the careful coordination. And, with most projects ended up with sort of various tools to deal with that. The starting point being sort of potentially a color-coded set of drawings that clearly defines which manufacturer or contractor is supplying and installing. So that is the steel components and the timber components. Certainly some lessons learned that have been reoccurring is there's a maturing of these solutions, and one of the things that we've noticed is a significant step ahead is timber manufacturers becoming contractors. So in other words, more and more they're offering added value to not only a supply of timber elements, but also in some cases supply of some connections and in some cases also erecting the structure. I can say with pride that our steel industry is quite a mature industry, so there are very clear processes that follow. So there are some challenges to get onto the same page around how we deal with this control, change management and control. And I know especially changes through detailing. So the detail that I've ringed in that picture was one that from a steel perspective, we weren't aware it even occurred. And so there's a bit of a mismatch there on expectations of what we were each building. I say eyes open because you actually need to be really holding hands. There's things that one party might not think are so important and yet might be critical to the other. So it's very much a team effort, and clear, concise communication is just key. So, once there's a set of design documents there, having those demarcations and the clear scope and expectations, which is what I mentioned here. So clear scope, definition, demarcation, that's really, really important. And we've got a much better feel of how that looks now. Part of the consideration around this, how do you pull two primary structural members or materials together, is the whole thing around lead times, different deliveries, different phases, using the same terminology. There's very different skill sets needed for the two components, steel versus timber. And what we've found on many of these hybrid projects, you actually need both on site most of the time. So they're so connected and interconnected that you need those resources available to ensure a streamlined sort of flowing construction sequence and process. One of the things we've learned a lot about is moisture content and how that affects timber on site, and also much greater appreciation that it changes quickly with weather. So it's imperative that some of the connections, if there's a consideration around moisture content and a limitation or limit before certain things can happen. For instance, the connection I've circled there couldn't be done unless the timber was within a certain moisture content. So partway through the job, they introduced slotted holes just to try and make that less of a critical hold point. So some of those things are really important to understand at the beginning of the project, because the critical nature with which the two trades work together, it needs to be seamless and trouble-free. So I'm just going to quickly touch on 3 examples. This building, all of these have been constructed. In this building, the coloured items are steel. I did a bit of a cross-check around how did that look from a project perspective. So the steel cost there equated to about $110 a square metre, which is a pretty significant cost. So even though it doesn't look like there's many members, there's quite a bit of detail in it. And, you know, at the beginning of any of these concepts and projects, and I'll talk a little more about this, I think it's really important everyone has their eyes open and expectations clear, because as we all know, budget and budget constraints are critical, and no one likes surprises. So, you know, these things are now becoming much more predictable and expected, and therefore better quality budgeting, having that knowledge. This is another example. Actually, all that you see on there, all of the members you see there are actually timber. It was, you know, largely, predominantly timber. And these are the things you can't see. So in this case, it had extremely complex steel connections, very expensive details to fabricate, and just the critical nature with how everything fits up. They were needed, you know, very, very high quality fabrication to fit up on site. So as a consequence, you know, very expensive. Now, this is first generation. Things have moved on. I think people now appreciate that there is this hidden cost that might not be apparent at the beginning. So, you know, there's a much greater awareness around more efficient connection details, avoiding this kind of extremely expensive component items. This is the third one. Again, a real project. A little bit different because it's quite a special area. It's big, wide span trusses, a big open area. It had a very significant amount of steel in it. Also a significant amount of timber. So it was a true hybrid, but again, I think everyone was a little surprised at the sort of final cost, and when you start sort of trying to boil it down, in this case, it had substantial steel supporting the timber, even though now, if you look at it, it appears to be a solid timber building. So I think there's a few lessons learned out of this one that, you know, that's potentially not the right mix. So just to try and summarize quickly, you know, first generation hybrids have provided some clarity on the pros and cons and the best combinations of materials. I think one of the recognitions we have as a steel industry is that, you know, it is very much about using the best material for the application and the use, and timber definitely has a place in the market. Our role is to try and sort of assist where we can in making that a really good solution. Risk is much better understood. So I think, we're kind of 5, 6, 8 years down the track now, and there's much greater clarity around how a hybrid building will look and how it can be built, which leads to much greater certainty on cost and programs. And clearly there's been development and, there's certainly improvements and more cost-effective low carbon hybrid solutions are evolving, which is what Alistair's going to be pointing to in terms of one consideration. So those are the key points we've taken from it. The market is certainly moving ahead. There's absolutely hybrid construction is here to stay. So it's about trying to make sure that you use sort of the optimum pros and cons to get that best mix. And that's it from me. Thank you.
Thank you, Wayne. Now I'd like to introduce our second speaker, Alistair Fussell. Alistair's the Director of Tangent Consulting. Alistair's had more than 30 years experience in structural engineering, including 22 years working for various consulting engineering practices and 11 years for SCNZ. He's a chartered professional engineer, a chartered member of Engineering New Zealand, and a member of the Standards Australia BD 0223 Committee, Structural Steel. A quick reminder before I hand you over to Alistair, please post any questions you may have into the question and answer panel. And please, again, don't post your questions into the chat as we may miss these. I'll pose those questions to both Alistair and Wayne at the end. So without even further ado, I'll hand you over to Alistair Fussell. Over to you, Alistair.
Okay, thanks, Darren. What I'm going to do, I'm just going to give you a little bit of an outline of where we're going to head in the next 25 minutes or so. What I want to do is give a little bit of an introduction to hybrid construction. Then I want to talk about a new design guide that SCNZ is producing with steel timber hybrid construction. As part of that design guide, we've been preparing some case studies on hybrid buildings, and what I'd like to do today is probably do a bit similar to Wayne. I want to give you a bit of an overview of just some case studies, talk about what were the drivers that led them to choose a hybrid steel option as opposed to something else. And then at the end, we'll conclude by thinking about what were some of the challenges, what were some of the lessons that these early adopters of this type of hybrid structure have learned. And then at the end, we'll sort of wrap it up with some conclusions. Sorry, that's not moving. Why is that not moving? Ah, there it is. Okay, so in terms of introduction, when we talk about hybrid structural systems, it's a bit of a generic term. Essentially, when we talk about a hybrid structural system, we're talking about combining one or two or more construction materials, and what we're trying to do is optimize the strength of each material to come up with an efficient and particularly these days a sustainable system. So we've seen, so if you have timber and steel, we might be trying to take advantage of the strength and stiffness of a steel member while getting the aesthetic values of a timber floor, and also the advantages of the reduced weight of the floor. With a steel concrete composite floor, what we're trying to do there is we know that steel's very good in tension, we know that concrete's good in compression, and if we put the two together, we can come up with an efficient floor. So Darren's mentioned that we're currently developing a new design guide, and it's called Hybrid Steel Frames with Timber Flooring. And the typology that we're covering here, and Wayne's already alluded to this fact that when we talk about hybrid timber and steel, there's lots of different options. You can have timber floors and beams and columns, but it puts only steel braces into the building. And as Wayne has shown with some of the jobs, there's a mixture of steel, a mixture of the elements in it. So the typology that we're covering in this guide, and that we think is a practical form of hybrid construction, involves having a structural steel skeleton. So this is your beams, your columns, your braces, and you put a timber floor on the top of the steel. And we think that this is a practical way to decarbonize construction. As we'll discuss, it can be a cost-effective and efficient way of building. The design guide that we're developing, we're grateful to the American Institute of Steel Construction. They developed a design guide 37, and they've given us permission to use their guide as a basis for our own. Obviously, things are a bit different in New Zealand, so we've had to rework it for our own context. We obviously have different building regulations, or we have different codes, material codes, loading standards, and also the building practice in this country is different than it is in the US. So in terms of the guide, why did we develop it? Well, firstly, we really wanted to try and facilitate the adoption of this type of building typology. So really what we're trying to do is to help designers who perhaps are more experienced with structural steel design than hybrid construction. We're trying to put front and center of them what are the matters that they need to be giving consideration to, particularly up front, if they want their designs to go well. So in terms of its development, we began our journey of developing this guide earlier this year. We've engaged a range of consultants with structural expertise to help us develop our guide. So we've got structural and fire engineers involved, acoustics people, sustainability. We've convened an expert panel of structural and fire engineers who've already undertaken a review of the first draft. And the game plan is that all things going well, probably the middle of next year, we should be publishing this guide. In terms of this guide, this is give you a bit of an idea of the content. So we can give you a bit of an introduction to mass timber construction. We talk about also talking about the hybrid steel frames with timber floors, giving some examples with case studies that we've developed. We're also talking about some of the advantages of this type of construction. We focus on structural design, and one of the really important areas of designing one of these mass timber floors is the design of them as a diaphragm, and we'll talk a little bit more about that as we go on. Fire is an important consideration. We cover that in good depth as well. Acoustics, sustainability, and we've also got input from builders and fabricators who've got some experience with hybrid construction, sharing some of the learnings from their experience of this type of construction. When we talk about hybrid construction using timber floors, what we have in mind with this guide is the use of cross-laminated timber panels. So these are panels that are made up of a number of plies. They come in different configurations. You can get them in 3-ply, 5-ply, 7-ply, and the different manufacturers come up with their own thicknesses of these plies. And so even for a given ply or number of plies, you can end up with a range of panel thicknesses. You can see there that they can span, even a 3-ply can be up to 4 meters. And once you get 7-ply, they can go between 5 and 7 meters. I suspect that's won't be a practical limit. I suspect floor vibration would start to become an issue if you were pushing them out. But in theory, that's how far they can span. One of the features of a cross-laminated panel is that if you look at the middle diagram in the right-hand side, you may not be able to tell, but the actual plies themselves they orientate them at 90 degrees. They alternate the direction of the plies so that they do tend to have strength or spanning capability in 2 directions. They can be made in quite long lengths, between 12 and 18 meters, and up to between 2 and 3.5 meters wide. So really you're more limited by transportation. Generally, once you get to beyond 18 meters or just over 3 meters wide, you'll need to get a pilot escort for your vehicle to transport these. One of the great advantages of these types of floors is that once you've craned them in place and screwed them down, you've essentially got an immediate working platform. You're not left waiting for concrete to cure before you can start working or walking on the floor or loading the floor. And they also have the advantage, this type of mass timber floor, of having an inherent fire rating. So when these types of panels are exposed to fire, charring of the surface leads to this formation of a protective layer. You can see it on diagram on the right, the lower one, and you can see the black charred layer. This provides an insulating layer, and there are recognized values of charring rates to be able to work out how much of your floor is going to be left after a given duration of fire. There may be some requirement for additional fire protection. There may be a requirement to encapsulate either with some sort of fireboard or intumescent coating of these floors. And the reason for that is that the building code is really written around having non-combustible structure, concrete, steel. This isn't the case with timber. There are some applications where, in order to reduce the fire load, that you may have to do some sort of additional protection of your floor. So what I want to do now is just touch on some of the reasons or the benefits of this type of typology that we're talking about in the guide, why we think that it's a good solution. The first one is aesthetics, and I'm sure I'm preaching to the choir here with as architects. You're well aware there's a growing interest in biophilic design, and the way we're seeing that is that we're seeing a lot more natural elements being incorporated into the built environment, and timber is a significant part of that. One of the things you can do with this type of floor, and you can see an example here on the right, is that you can actually expose the floor panels and the steel beams with minimal additional architectural finishing. You might just need to give your steelworks a nice coat of paint, and you might want to think a little bit about how you reach your surfaces, so at least it looks like there's some thought gone into the layouts of your surfaces. One of the big advantage of using steel beams is the spanning capability. You can easily get 8, 10, 12 meter long floor beams if you use steel. Conversely, if you're going to use timber beams, mass timber beams post-construction, they can become quite inefficient once you get spans that are greater than about 6 meters. You also, this type of construction has sustainability benefits. The CLT panels, obviously they have a low embodied carbon. The structural steel also has a good sustainability story. We're seeing increasing adaptive reuse of buildings. Often buildings become functionally obsolete long before they need replacing or demolishing because of deterioration. And so when you use a structural steel building that has long spans, it gives greater flexibility if there's a change of use in the building. Also, structural steel buildings can be readily strengthened if you wanted to change the type of floor loading or you wanted to add extra floors to the building. It's relatively easy to weld, bolt new structure to an existing structure. Steel is also readily reusable, so essentially a steel building is essentially a spare parts warehouse for the next steel building, and there are initiatives now that will help facilitate that in the future, in the next 100 years or so, when these buildings that we're building today perhaps come to the end of their life. And one of these initiatives is the Steel Passport. So this is really where they're developing systems of being able to capture information about the steel that's gone into the building, so its grade of steel, its mechanical properties, what coatings were put on it, the sustainability properties of that steel, so that in the future they're really available to be able to have the steel sold so that it can be reused. There's also greater thought going into designing for deconstruction so that it's actually easier and more efficient and cost effective to actually deconstruct a building rather than just to demolish it and essentially end up with everything, the structural steel, having to go and be recycled. And the final aspect of the sustainability of structural steel is that, unlike a lot of other materials, once you get to the end of life of the structure, there is a ready market for scrap metal. There's a very high recycling rate with structural steel. It has good commercial value. And it's used again in electric arc furnace steelmaking processes to create new steel, which has a much lower embodied carbon value than having to create steel from virgin steel from iron. One of the other big benefits of using structural steel beams is it's much easier to integrate services into the depth of the beam. So with structural steel, you can put pretty large penetrations into the webs of the beam, and you can see there an example from one of our case studies where the circular penetrations of the beam. If you have to pass your services under the beam rather than through the beam, you end up having to have increased floor depths, which obviously increases the height of the structure, the amount of facades, etc. you have to put on the building. One of the other big pluses of this type of construction is that you get is that a timber floor is quite lightweight compared to a concrete floor. Obviously, if you can reduce the weight of your superstructure, then the requirements for your beams, your columns, your foundations, your lateral load resisting systems are reduced. This obviously has big advantages if you've got poor ground conditions where foundations work is going to be quite expensive, or if you're in a region of high seismicity, extra structural weight is really just a bit of a liability for you, as your earthquake loads will be a lot higher. You also get the benefits of construction efficiency. So CLT panels and structural steelwork are prefabricated systems. Both of them are manufactured in factories using automated equipment. So they use 3D modeling, which gives the inputs into their computer-controlled CNC equipment. So you get all those efficiencies. And when you can set yourself up in a factory, it's easier to control the environment, to get the quality you require. You can set yourself up so that it's easier to do things, so it's more efficient, and you can not only do it easier, but you can do it safer in your factory than you can on a construction site. And once the fabricated product gets to site, it's very quick and easy to erect. So CLT offers significant construction efficiencies compared to a traditional floor. So if you imagine dropping in a 18-meter long panel that's 3 meters wide, that's quite a lot of floor area you're covering in a very small time when you place it. And if you were to replace that with perhaps timber joists at 400, 600 centers, you add blocking to it, you put a flooring on it, you screw it down, it's way quicker to just drop the panel in than to do that. And structural steelwork, it's just like a giant Meccano set. So the steelwork comes to site either as individuals, members, or as fabricated components, and it's bolted together on site. Very quick. They generally don't, these days we don't get much site welding, so it's a very quick process. So that's really just a bit of an introduction to our guide and to the hybrid typology that we're suggesting has a lot of merits and encouraging designers to think about utilizing. What I want to do now is to go through some of our case studies, talk about, share with you some of the drivers for those projects, why they decided to use the typology they did, and then also share some of the challenges or some of the lessons that they have taken from their first experience of this type of construction. Before I start, I want to acknowledge the engineers and the builder that helped us with these case studies, that not only obviously shared information, but also shared images, shared drawings of these projects. So I want to do that up front. So the first case study is the Manaaki Ora project in Rotorua. This was a Rotorua-based health organisation. This is a 3-story building. Floor area 1,500 square metres. They had a 5-ply floor, 155 millimetres thick. The structural bracing system, you can see from the picture on the right, they had concentrically braced frames running down the side of the building. They had steel moment frames in the cross direction, and then the CLT flooring was supported on top of the steelwork. You can see that down the bottom, there's a diagram showing a cross-section through the beam and the floor. So they had spline joints over the beam. They also used half lap splices in the middle of the floor, which I haven't included in this diagram. So in terms of the drivers, why did they choose to use a hybrid structure rather than something else? Well, it was quite a challenging site. There were challenging geotechnical and geothermal conditions. And so for them, it was a really big plus to be able to reduce the weight of the structure and make life easier for themselves. They were keen to use a natural product in the floor. They wanted the construction efficiencies of a prefabricated element as opposed to, as I said before, constructing a traditional timber floor. They really liked the idea of combining the warmth of the wood with the strength of structural steel. The second case study is a office building that this was for the Lyttelton Port Company. They were building a new operations and maintenance building for their new straddle carriers. So in their operations, they were changing to these new straddle carriers that could lift and place containers up from 3 to now they were going to 4 containers high. So obviously they were going to get a greater capability without having to have new land, and so they needed a new building to service that. They developed, also had produced or constructed an office, 3-story office building. So it was just over 1,000 square meters. There was a 5-ply floor, and in this particular case, they had concentrically braced frames as the primary lateral load resisting system. So why did they choose a hybrid option? Well, they were the port company was keen as part of their sustainability agenda to come up with a way of reducing the carbon footprint of their building while coming up with something that would be practical to build. The reduced weight of the structure made a difference to the design as well, and they were certainly keen on the efficiency of construction efficiency of CLT. Like most projects, they had tight construction deadlines, and they felt this was going to offer them that advantage. The third case study was from Wellington. This was the Wellington City Mission project. This was a community facility. It was going to serve a number of functions. It was a 5-story building. This one's a bit bigger than some of those other projects. So this was over 5,000 square meters. This one included was a 5-ply CLT floor, and it used, unlike the other ones that had brace elements, steel elements, this used a 2-way moment frame. And part of the reason for doing this 2-way moment frame was that the brace frames had quite high uplift loads on them, and it was quite difficult to make the foundations work. So this really suited their project. So the reason that they went for this hybrid option was that the timeframes were really tight on this project. When they first started the project, they had a few buildings that they were going to upgrade, and they were going to do some refurbishment work. Very soon, it became apparent to the designers and the owners of the building that there were going to still be a lot of limitations, even after they'd done all this upgrade refurbishment work. They probably weren't going to get a great outcome. So they ended up pivoting to a new build. The government had they had secured government funding under the Shovel Ready program, but they had to start by a fixed date if they were going to get the funding. And to avoid a new resource consent, they had to stay, or the building had to stay within the consented envelope. And also the structural engineers had to essentially come up with a structural system, new structural system that would work within the confines of the developed architectural layout, because that wasn't going to change anymore. The other one, the other driver was this construction efficiency, and this really came down to this tight time frame that they liked the advantage of a CLT floor. They also, the weight was important as the foundations were. It was going to be tricky to make the foundations work with a heavy structure. And the other really big plus was that the steel beams were a lot shallower than they would have been if they'd been a mass timber beam. And that was really important with keeping the building within the building envelope that they had a resource consent for. So now I'd like to just draw some of the lessons that these first generation of designers have learned from their experience of these types of buildings. I've essentially just morphed them all into one. I'm not going to list them by buildings. Some of these came up in all of them. Some of them might have only come up for one project. So I've just selected some of them, a group of them. So the first lesson was that they certainly recommended the use of a federated building model. So this is really where you have a combined model of the structural steelwork, the CLT panels, and your building services. And really what they're saying is that it's much easier to build a digital building and detect your clashes rather than send the job to site and find that you've got problems. Once you lose a lot of the advantages of prefabricating your building if you find that on site you have to retrofit where you've got a problem. You might have overlooked the fact that you had, for example, some connections on top of the steel flange and you didn't route the beam. If you were craning a panel into position and you suddenly found you had a problem, you've got all the delays of having to site route, and you've got the hook time and everything. So you really want to try and sort it all out in your model before you even get to site. CLT supply was identified as a real issue. So it's only limited amount of supply, and also the suppliers of CLT pretty much, their lead times are quite long. So what they're suggesting is that you really need to lock in your CLT suppliers really early, and that's even having them as a nominated subcontractor even before you have a main general contractor on site. And the reason that this is so important is that when it comes to these CLT panels, the sizes, the spanning capability of these floor products are very much manufacturer specific. So you can't just interchange like you can with a metal deck floor where you might go and allow a swapping with somebody else's product. You can't do that. So you're essentially locking your spanning capability, the thicknesses, everything that you lock in early. You have to stay essentially with that nominated supplier. And so really what you need to do is get into their production schedules early and secure it so that by the time the project or the steelworks come to site, your CLT's all good to go. Fireproofing is something that obviously fireproofing is important for all types of construction, but there are some particular issues that you need to consider with particularly mass timber and hybrid structures as well. And one of the designers rightfully noted that the behavior of hybrid buildings and fire is an evolving science. So you really want to get your fire engineer involved early. One of them had a bit of an issue where they developed a fixing detail between their steel beams and their floor that they had to change. So they originally, if you look to the just to the right and lower right, there's a picture there showing a beam where you've got screws going into your floor. When they did their first design, they had screws going right through the floor, and these pretty quickly got retarded by the fire engineer. Essentially, they created a thermal bridge so that you would get heat transferring through to the top of the floor, and they ended up having to go back to screws. So the lesson is get the fire engineers involved early and understand what those requirements are. One of the key things you have to do with these types of floors is prevent heat and smoke transfer through the floor. Now, this is a bit more tricky when you don't have a concrete topping. So in the US, they do put concrete toppings on floor, so you don't have the same issues of having to be so careful in preventing smoke and heat transferring through the floor. So you really have to look closely at fireproofing the penetrations through the floor. So this is when you have your wood, your panels as they go around steel columns, where you get your floor butting up to walls, where you get the joints between the floor panels. All of these things need to be fire rated so you don't get heat and smoke passing through those joints. So all the joins with the CLT floor had to have fire rated sealants in them. They needed to have fire rated collars go around the surface penetrations through the floor. One of the engineers reported that it was difficult to get fire-tested collars to pass through the timber floor. So I don't know if that's changed, but that's just something to be mindful of. The other thing, the lessons there is around service penetrations, and really the lesson there is that you need to get early coordination with particularly the services engineers to make sure that the floor penetrations are incorporated into the floor, and beam penetrations are incorporated into your shop drawings. It's so much easier to put the service penetrations on in the factory than it is to retrofit and have to put penetrations into your structure on site. The building code has requirements around the transmission of airborne and impact sound transmission, and so really one of the requirements there is that you have to resolve your acoustic issues early. You have to recognise that some form of acoustic separation layer between your floor and your steelwork, or some sort of floating floor, is going to be required. If you're trying to reduce the transmission of airborne and impact sound, generally you have to either add mass to your floor, you have to create airspace, which is a bit like double glazed windows, and they do that with these things that you can see on the right bottom hand side. There's an example of a floating floor with different cavities in there, and you have to add resilience to your floor. This is like putting underlays or pads between the floating floor and your structural floor to reduce the impact, transmission of impact sound. And then obviously this has structural and architectural implications. You add these floating floors, you add seismic weight, you increase the floor depth, that changes your floor-to-floor heights, and there's obviously careful detailing required to make sure you don't get sound transmitting around through the structure into other spaces. Wayne's touched on this one. Moisture management is really important. The structural timber, you're trying to keep it below 18% water content. Once you get above that water content, the timber starts to swell, being a natural material. Not only does it swell, which creates, as Wayne's already alluded to or mentioned, tolerance issues. It also you can result in staining. If you get water on it, you can get mold growing on it. And so really the very clear message there is about protecting your floor from moisture. So some people have tried, they shrink wrap their building. Others times they individually wrap their CLT panels in plastic. So they either wrap it in the factory or they use adhesive wrappings that they put on site once the floor's been laid. Another, and this came from the builders, this is around the building sequencing. You've got to be really careful in planning your erection because you've got to balance. On one hand, structural steel typically gets put up in 3 to 4 story lifts, and that's really makes it quite efficient. So you really want to get as much structure in place as you can. But on the other hand, you don't want to snooker yourself by not being able to get the timber floors back through the structure to lay them on the structural steel. So you've really got to think very carefully about what structure you put up, what elements you leave out in order to allow the panels to be craned in position. One of the things that is a bit more limited about a timber diaphragm is floor diaphragm is that they're not as strong and as stiff as a concrete floor. And so that your floor in a building not only has to resist vertical loading from the contents of the floor, etc., and its own self-weight, but it also has to transfer horizontal loading to the vertical braced element. So this horizontal loading could be wind applied to the side of a building, it could be earthquake loading, and so it has to distribute those loads horizontally to the bracing elements, which could be moment resisting frames, or it could be some sort of braced frame. So at the top right-hand diagram, you've got a structure there where you've got brace frames in the cross direction at the end of the building and around the services core. And if you have widely spaced braces, it can actually be quite hard to make a timber diaphragm work by the time you're trying to design to resist all these horizontal loads, and you can end up with some quite complicated diaphragms, which can not be very practical to actually build. So really the lesson there is it's better to use CLT floors when you either have lower seismicity, so your lateral loads aren't as large, or you try and avoid having too widely spaced vertical load resisting elements. So in this case, the system that works really well with it is steel moment frames, where you generally have quite closely spaced moment frames in a steel building, and so the demand on the CLT flooring diaphragm isn't very high. So now I'd just like to draw the threads together of what we've said. We think that this form of hybrid construction of steel frames with timber floor really combines the best of wood and the strengths of steel. So you get the warmth of the timber, the strength of steel, and we think it is actually a practical way of reducing the carbon footprint. And the reason we think it's practical is that these types of buildings can be cost effective and they can be an efficient form of construction, but there is a caveat to that, and that really is to say, if you want to realize those cost and time benefits of this form of construction, then you have to make sure as designers that you have your design completed and coordinated up front. With concrete type buildings, you can almost be putting penetrations in as the concrete truck's on the way to site for a beam. It's a lot easier to accommodate it. When you have prefabricated trades, it's so easy to put penetrations and account for things in the factory, but the moment you have to sort out a stuff up on site, it becomes very expensive and very time consuming. So if you want good value out of it as designers, you have to do more work up front so that you pretty much have a locked and loaded design by the time it goes to shop drawing. It also requires careful planning and sequencing by the builder, so they have to think carefully about how they're going to build the structure to make sure that they can actually get an efficient erection of the steel and placing of the panels. And you also need to get your CLT supply locked in early. It's likely that they're going to be your critical path element, so you need to make sure that there's no point getting your steel structure up and then be waiting around for your panels. And we'd also say that it's not going to suit every project, this typology. If you have very high diaphragm demand, it probably isn't going to be a good solution. If you have stringent vibration performance requirements, you might have something like where you've got like a hospital where you have requirements for operating theatres. You might have sensitive equipment that it won't work. If you have a high fire rating requirement, it may not necessarily be the best solution either. And that's the end of my presentation. So back to you, Darren.
Thanks, Alistair, and thanks, Wayne. We've got some questions. So someone must know my mobile number because I've had a couple of people send me questions through. But first up, we've got for Wayne. Wayne, can you give a further explanation of the risks and what it means?
I think that's the key learning out of sort of the experience to date. With anything new, there's a bit of uncertainty around how to price it, what the expectations are. So I think for all parties involved, there's much greater clarity around how these things go together, what to expect, should mean more efficient pricing and less risk factored into it because it's a much better known factors involved.
Thanks, Wayne. This question came online, and I'm assuming it means during the construction process, but are there any issues with fire? I suppose we've had a couple of fires on construction sites recently. So
during construction?
During construction, yeah, I'm assuming that's what it's meant.
I guess the answer is yes, like many or all projects, there is an aspect to that. Alistair, maybe you're better to answer about the risk of construction fire. Or
Yes,
fire arising.
Yeah, this definitely is an issue for this type, or any type of these mass timber buildings, particularly during construction. So yes, you do have to be careful. I mean, they're not insurmountable, but you just need to be aware of the issue and the risk and manage it. Yeah.
It has been said that hybrid construction requires a shift in mindset. What does that look like in practice for architects?
Well, maybe I'll do a quick comment. You can too, Elsa. From our perspective as a steel dominant contractor, it is definitely a shift in terms of sharing knowledge and ensuring clarity on both detail and scope, because it's not a one solution constructions solution. It does involve multi-parties, and so it's just the critical nature then of ensuring consistent information that is shared across all the key stakeholders, because like I mentioned, we had a few issues that arose through sort of design change that wasn't communicated very well. So all parties need to know what's going on rather than expect one person to be responsible for it.
And another question, a similar vein, what message would you give to architects who are studying to explore hybrid construction but haven't taken it on yet? It's a good question.
Good one for you, Elsa.
Okay. Well, look, I think with this, that I remember talking to an engineer who's a real expert in timber design, and I think his comment to me was, just because you can do something in all mass timber doesn't mean you should do it. And I think my comment, or what I mean by that is, if you have an idea for a great mass timber building and you're thinking this is going to be the solution, my suggestion is, or even if you're going to do a hybrid one where, like some of the ones Wayne's looked at, maybe speak to your structural engineer, maybe get some builder input before you lock into your concept, because some of these structures have actually, when they go to build them, have become extremely complex. They've been very slow to build and very expensive. So I think you just, before you lock in on a concept, that you get some advice on cost and buildability before you sell the design to the architect and your client and have them in love with it.
Yeah, I think that's the importance of this lessons learned. It's exactly what I was meaning about risk and the known. It's where everyone knows much more about it now, and hopefully there's fewer surprises and more certainty on cost at the beginning.
One that came through my phone is, how can we, and I'm assuming this is the architects, identify steel fabricators who are capable of undertaking these hybrid projects? How do you know if they've got the right quality systems in place?
Well, probably one for you, Darren.
That's right.
I can answer that. I've read it and answered it. We have a industry quality scheme called Steel Fabrication Construction. It's called SFC certification. Steel Fabrication Certification. It's independently audited by HERA Certifications, and we've got about 70 of our fabricators who have now got it to CC3 of AS/NZS 5131, which is the standard, and it's a way of showing that those fabricators are independently audited to be able to achieve quality. So I would recommend that you ask for that if you want to see people's quality. That's a good question. One about with mass timber floors, it's probably for both of you. Are there issues with protecting the floors from moisture during construction? And someone also asked, what happens to all the shrink wrap after you've taken it off? Does it end up in landfill? I don't know if either can answer. I guess it's one for the timber guys.
Just quickly, I'll comment on the water on the floor. Yeah, absolutely. It's a consideration for the main contractor. The one that I showed many photographs of, they actually had people every few hours vacuuming water off the surfaces, trying to keep water away from the CLT floor. So it's very much a consideration that needs to be planned for.
Thank you for that. This question came out from on my mobile as well. So in terms of the detailing, who is best to be doing it? You could have 3 or 4 different parties all doing detailing.
Look, it starts with the consultants, both architect, engineer, the quality of the level of design and detail that's incorporated at that stage. But I don't think that there's any value in trying to have one party detail all, because it's kind of a one size doesn't fit all. So, I spoke about tolerances, and the detailing and shop drawing process is when, if it's not already communicated in the design documents, that is when you need to consider it. So steel detailing is quite different from detailing steel in a timber structure. So, typically we're seeing an emergence, and this is the maturing of the industry, that the mass timber manufacturers typically are also detailing the timber to timber connections themselves, because it's fully within their control, and the steel fabricator is detailing the steel to timber or steel to steel items. And so hopefully you've got the best knowledge of both. And I don't think there's a solution of any party that one party could do all. I'm not sure that expertise exists, to be quite honest.
Well, I think the only comment I would say is that one thing that seems to come out of this is that some of the builders now who have good sort of BIM capability, I think it seems to work well if you can get a builder who's prepared to have a combined model once you've done yours and the panel manufacturer. Because the problem is, you take responsibility for your work, the CLT person takes responsibility, but if there's a problem where the designers haven't coordinated, you're all blissfully ignorant that when you put the two together, there's a problem. And I guess that's where I think now good hybrid builders are going to be companies who have good digital capability, so they can take all the models that are being generated, overlay them, and identify if there's clashes. So I think that will certainly help if there's builders, because at the end of the day, somebody needs to take responsibility for doing that. And I think the good builders in the future of hybrids are going to be the ones who do that. Yeah,
you're absolutely correct, Alistair, and that's happening across all materials. So the whole idea of sharing models, when we do shop drawings, our model is the most accurate of all things in relation to steel, and then the timber guys are the same. So you've got to bring those together to make sure you don't have clashes, and in fact that they're consistent, those interfaces.
So it must lend itself to early contractor engagement is critical. Yes, particularly for these buildings. It's critical for all buildings, but this one sounds like it's even more critical.
Yeah, very much.
Well, we've got one more question, and then we better wrap it up. So with a hybrid building, I don't know, maybe this one for you, Alistair, how much waste ends up in landfill from steel and timber shrink wrap, I suppose?
Well, I mean, I don't know what happens to it, and I don't know if it's biodegradable. You'd like to think that it was, but I couldn't comment on that because I haven't done one. I mean, I know from the structural steel industry, there's so much value. I don't know how many $100 per ton of steel you get, that steel fabricators are, they sell it to the scrap merchants. So there's pretty much very little waste. And I would imagine that with the, I don't know, I couldn't speak for what the CLT manufacturers, but hopefully they've got a fairly customized process in terms of making up their panels with it. And, they'd have to speak to that one. I couldn't tell you, to be honest.
I guess the steel will be going back to Glenbrook as an electric arc furnace, which they're installing later next year, and end up being electric steel. So. Well, everybody, that wraps up. I'd like to thank our speakers, Wayne and Alistair, for their contribution today, but mostly I'd like to thank all you for your time. And thank you for NZIA for allowing us to host this, and I hope everyone got something out of it, and we hope to see you again sometime. Enjoy the rest of your day. Thank you.